but just kind of who, what, why, when, where. So who's the ESS group? So that's my group at Bridgestone. We're a subsidiary of the team that builds the machines that build the tires. So inside of my group, we do everything from CAD software training, implementation. I have CAD designers that work for me full-time. We have electrical designers. We have teams that do implementations of new technologies, CMMS, things like that. And then out here by himself, we have Brian. So Brian is my innovation manager. He's going to talk to you guys a little bit on the technical side. And I just kind of want to share this with you that, we're out here to try to make the engineer's life easier. That's our goal. And whether it be through a technology like software, AR, VR, FEA analysis, things like that, laser scanning, we try to get it out there. We have Project Marty, and we started this in 2015. We started doing laser scanning very heavily. We seen that the HTC Vive was coming out. Hololens obviously had been talked about for several years. And so we said, you know what, we need to bring these technologies together and form a team. It was a cross-functional team from multiple departments, and we called it Project Marty, mix augmented reality technology and innovation. And we shared this with the executives, and they loved it, hook, line, and sinker. Very much careful what you ask for. We got so much excitement going that they expected this to be done the next day and want to know why we weren't. So, 2015, early 2016, we started Project Marty. Our first app was VR Design Review. We'll go over kind of what that means here in a second. We got into the HoloLens apps doing AR testing. So, we were going through all these different vendors. There's a ton of great vendors out here. Just a little tidbit. We try to stay as software and hardware as agnostic as possible because you never know when one of them's going to go away. Some of the really good ones have come and gone, and unfortunately, we want to make sure that we don't lose that technology or lose that information as we go through it. VR Design Review as a product internally, we pretty much standardized on that last year. And then we started getting into the AR stuff. We're doing a lot of work with Microsoft and some of their tools. And then kind of the next step is going into IoT and Industry 4.0. So a day in the life. So what are we talking about a day in the life? So we're talking about a day in the life of the XR process. So to us, it goes through kind of a life cycle like anything else. So the first step is VR Design Review. You got an idea about a machine, you think it might look like this way, so we'll do a VR Design Review with it. The next step is AR Design Review for maybe it's an existing piece of machinery, maybe we're going to be modifying that piece of machinery, so we do AR Design Review at the plant on the piece of machinery. Our machinery is very large. We're talking about 5-story building size, a couple 100 feet long, 100 feet wide. It's just one piece of machinery. VR training. So before the machine's up and running, we want to be able to train the users before we're wasting materials. It costs a lot of money if users having quality issues or you have to have somebody go back and verify they're doing it correctly. And then AR training is something that we've just recently gotten more into, where we're going through it and we're telling the guy, don't forget this step. Go through these 200 steps to build a tire. And then AR on the plant floor, we're talking about IoT. We've started doing some IoT stuff with a different group internally, and we're trying to tie that into the VR. The biggest issue is getting all those things to talk together in the background. So why did we start with the VR for design review? Ease, speed to market. It was very easy to get these super complex models in the HTC Vive. We're able to get some very powerful PCs all relatively cheaply. A couple $1,000s you can get started. You talk to the guys at Boeing, you talk to some of the bigger guys, they've been doing this for years and they were spending millions of dollars to get this technology. We were able to do this with thousands of dollars. Our first VR system cost under $5,000, including the headset. And so we're able to get out there and do these design reviews very quickly, very easily. We were still doing some development with AR at the same time, so we're dealing with the VR for design review and playing around with AR, seeing what we could do with it, seeing what size models we could actually get in there, and go through the actual AR headsets as well. And I'm kind of going through this quickly because I want to turn this over to Brian. And Brian's going to give you guys kind of the technical why we did it this way and kind of go through that with you. You go, Brian?
Yep, thank you. Can everybody hear me? So what you guys see here is our workflow. This is kind of just a very high level overview of what is our process. And it really starts with Revit Inventor. As Andy mentioned in his previous class, we are an Autodesk house, which is how it's come to be. That's the software we use. So we start with Inventor, and really with Inventor, that's where we do all our modeling of our machinery. Why we like Inventor for that is that we can export actually out of Inventor as an object file, and what that allows us to do is when we're trying to convert into VR, it actually carries over the material, so I don't have to recreate the materials. You move from Inventor really into 3ds Max, and that's kind of our, how do we clean up the model, how do we make it less polygons, how do we, especially for AR, is trying to, how do we do a better performance for our model? And then that moves into Unity, and so we happen to use Unity. There's other programs that you guys can use. We stuck with Unity, is what we worked with in the beginning. Unreal has a great VR plugin tool also. Then we go from there and we decide, are we going to do VR or AR? And VR, again, we're using an HTC Vive. You can also use Oculus, and then HoloLens is kind of what we're focusing on right now. Moving a little bit more, I wanted to show you guys, how easy is it to really go from step one, high level, over through how do I get it from, I've got a model in Inventor, I've got a model in Revit, how can I put it in VR? The first step of the process is really bringing that model into 3ds Max, or if you're using Maya. And for us, it's a simple import. As you guys can see, it's super easy. And then once it's in there, you have the option to clean it up. You can change textures, model, additional pieces, whatever you need to do. But really what's important for us is the exporting of it. So there's a tool within 3ds Max under the rendering called Scene Converter. And what Scene Converter allows us to do really is take that model that might have multiple textures, multiple pieces, and basically, I'd say shrink wrap it all together as one package. So that when we use a scene converter and we bring that model into AR or VR, it's a single component. So once you use the scene converter, you've got the scene converter, and the next thing to really do is now we're ready to export it. And this export's what's going to bring us into Unity or Unreal or other programs. In here, you just do a simple export as an FBX. The one thing I want to note here that's very important is the units. Bring it into Unity, put it in meters. If you guys put it in inches, your scale will be off. So that's just a good note. So then we start with Unity. Unity, just like Unreal, you guys have a main page is I want to create a new project, and you're wondering, I don't know what to do. Where do I go? I've got Unity installed. I'm running it. How do I start a project? And so in here, what we do is you just create a project, and then the important thing for HTC Vive is it uses the SteamVR plugin, which is in the asset store of Unity. If you're using Oculus, there's a separate Oculus plugin you can also download. So with the SteamVR, is you want to download it and import it into your scene. When you import it into your scene, everything you see right there in the box, which you guys will see a copy, I know it's a little small, everything's selected or pre-selected. The reason for this is all the scripts that allow us to teleport, allow us to interact, allow us to create animations, allow us to start a VR project so that when I put the headset on, I can move around, I can look around. And so after that, the next step we really do is, for me, I always create an imported assets folder. So as you're bringing in assets from outside, whether it's Inventor or Autodesk or another program, is I store it all in one location. Then once you get the assets in there, the next step we go is what's really important, I've learned this the hard way several times, is when you import SteamVR into a Unity project, it doesn't actually create any input. So if I were to just drop something into the scene and say I want to hit play and see what it looks like in VR, you can't interact with it. You can't teleport, you can't hit any buttons, nothing will really work. So with here, under the window, you'll see the SteamVR input. Well, all you have to really actually do is when you load that up and the SteamVR input opens the number 2, all you have to do is hit save and generate. And what that does is it generates the default mapping that the Vive has in the SteamVR. So things such as clicking or pulling the trigger for grabbing or teleporting, that's all default. This same menu allows you to actually modify that, which you can modify with scripts and change those kind of things. But for now, obviously, it's just going to be a save and generate. And then this is the important part. How do I create something in VR? I bring a model in. So the first thing you want to do is actually add in the player component from the SteamVR assets. So what that player component really does is it adds in, attaches your camera to your headset. So when you hit play or have your headset on, it's tracking you. If you did not do that and had the default camera that's always set up in a Unity project, it wouldn't go anywhere. Then the next important part is you need a floor. You know, if I want to be able to teleport, I don't want things falling through the floor, we create a floor. And so the easiest way to do that for Steam is you create a plane, you make a copy of that plane, you then nest that copy of the plane under your floor. I, of course, labeled it teleport area. And then you attach the teleport area script to the nested plane from, again, your SteamVR assets. It's almost just you browse through these things and find these scripts. And so what that script allows you to do is it allows you to freely teleport with the jump command where you pull a trigger and you see a little hop. It allows you to freely teleport. There's other actual scripts that allow you to, if, hey, I'm at this big machine, but I only want 3 or 4 different areas I want somebody to teleport to, we can actually lock teleport locations. And again, those are just simple scripts that are included. And then we add the teleporting component to the scene. This is what allows us, with all the other scripts, to pull that trigger, jump to one place or another, and freely jump, and whether or not we want to lock out certain areas or just freely roam. One big note, and I learned this again the hard way, you have to remove the default camera. Anytime you start a Unity project, there's 2 things that open up in the Unity project, directional light and default camera. So if you don't remove the default camera, again, the player script actually attaches a camera to your headset. If you don't remove it, those things mesh and they don't work. Now, the next thing we do is we're actually going to import, once we create the flooring, is we're going to import our actual model that we had created into the scene. And it's as simple as literally dragging from your assets folder up into the main scene. You can check your scale. There's when you insert a blank game or a new game object such as a cube, its default scale is 1 meter by 1 meter. So that's the general area to help you check your scale. And then preparing it for VR. This is what I really like about SteamVR and using the Unity platform is as you're building these scenes, or as you're building your VR model, that whether it's for design review, you have the ability to do a live preview of what you're editing or what you've placed in there. And really the way to do it is you need 2 main components. First one is you need a VR headset. In our case, for the HTC Vive, you need Steam installed. It's a game platform. And with that installed, there's a SteamVR component of it. And what you see here is once you have your headset hooked up and you've run Steam, the little box pops up in the bottom. When those all 4 go green, which is basically your headset, your 2 controllers, and the 2 lighthouses that come with your Vive, you're ready to, all you have to do is hit play. And when you hit play on Unity, it's a big button, you hit play, you can actually interact with your scene real time. And so you can see, what did you just do? What are you able to do? And it lets you build on that. Obviously, what I've shown you right now is really just a basic teleportation. For VR design review for us, when we started out, that's all we needed, just to be able to see something of the size of the machinery we have and be able to walk around it. This setup process here, if you've already got a model that you're ready to convert, this will really take you 2 hours. You know, and so being able to start a project and go in there, drop your model in, and put a VR headset on and show someone, for us, it's showing our engineers, the ones who are designing it. You can do in a few hours. And that's very basic. Obviously, there's other things you can do. There's additional scripts for interactions if you want to be able to grab an object, throw an object, physics, adding buttons and animations. But for the sole purpose of design review, you know, that's all we had to do. So to recap, some of the benefits of virtual reality for us was obviously speed to market. Being able to, what I just showed you, being able to put that into a VR project, so to speak, where I can launch it and show you exactly what you mean when you tell me, this is really 10 feet tall, I can see that. Again, full scale. Being able to put a piece of machine that I can't fit in this room into a VR project where we can actually walk around it. And then the ability to allow earlier collaboration between operators and engineers. This one Andy's going to talk about a little bit, so you can see that picture in the bottom right.
So, you know, we wanted to show you how simple it was to get something in there and get started. Something that simple, we were able to do, you know, a VR design review here. Just so happened the engineer that designed this new piece of machinery, the guy's literally 6'7". See the guy in the red shirt? He's the other engineer working on the project. So we have 2 just super tall guys working on this project. They go through, they design the machine, they spend weeks and weeks and weeks working on this, coming up with the best workflow, how they're going to automate this machine and make it work. We take it out to the plant floor. We grab that operator there that happens to be in the orange shirt. The guy's about 5 foot tall. We put him in the headset. He goes to reach that roll, and he goes, "There's no way I can reach that top roll." He was having a really hard time with it. He said, "I couldn't run this piece of machinery." Had we physically built that piece of machinery, it would have cost us about $35,000, probably about 6 weeks' time to modify it to be able to have any operator operate it. But with VR, we were able to catch that very early on that somebody just casually overlooked, didn't think much about, and save that $35,000 change order because to change it from a 3-roll to 2-roll system was pretty quick, took a couple hours, and we were able to change that design. So with something as simple as the process Brian just walked you through, we were able to get in there and save money, on almost the first time we used it. We've done about 20 design reviews with this, and we do them in our corporate office. We take them out to the plants and do them at the plant. Usually it's in a conference room or something like that where we're using, maintenance techs, operators, and we're actually giving them a chance to go through and try out the machine in real world, or virtual world, I should say, and be able to see it before we ever cut that first piece of steel and find out that something's not going to work. We also found a lot of safety issues. The previous machinery, we had a lot of what they call shoebox injuries. Just so happened when this machine moves around, there was these little pockets that would open up about the size of a shoebox. Operators would step in and twist their ankle, and we were able to catch that virtually a little bit, but the problem is this machine moves at certain times. There's different plates that have to move, and we're able to catch that with VR much easier than just having a CAD guy sitting there looking for these, not realizing what they were. The operators knew exactly what they were looking for. They're like, "Hey, watch out, this is gonna catch my foot right here." And so we were able to find these and save these safety problems with, like I said, very minimal effort. So with that.
So we're gonna move into augmented reality. So part of what we do is we do both virtual reality and augmented reality. Several areas of augmented reality that we do is similar to VR design, layout reviews. Except our layout reviews would be in the plant at seeing how a new piece of equipment fits next to an existing piece through AR. Similar to VR, the process is roughly the same in terms of getting it into, I want to see what it looks like in AR. Excuse me. So again, we create a process, but instead of downloading SteamVR from the asset store, the other tool we actually download is the Mixed Reality Toolkit. It's available free online. It's usually in the Git repository. Similar process. You import it just like you do for the SteamVR. The only difference is when we import it, the first thing you want to make sure is that the main camera, your clear flags down there set to solid color and the background set to black. The reason that is important that you do that is that allows you, when you actually show it in a HoloLens or an augmented reality headset, the black is transparent. So if you had that as a different color, you would actually see that color mask over whatever you have in the augmented headset. So the setup process for this is similar. What's great in the Mixed Reality Toolkit is they actually have a scene example called Interactables example. And what that allows you to do is when you first set up a project and you've never done an AR project before and you don't know what you can do in AR, that Interactables example actually loads in all these samples of what you can do with interactions, buttons, how to make things move, animations, all of that kind of stuff. I always start with that one if someone's never done it before. But the important thing is if you do use that, you can actually use that to set up your camera, your lights, your floor, all of that stuff. But what I'd have to do is delete the scene description panel and Interactables. If we don't do that, all of that content's going to be in your AR model. And then, of course, the next thing we do is pretty simple, is you add in your imported asset. So the thing with the imported asset is it's the same import process, so coming from Inventor into 3ds Max and exporting as an FBX. There's a little bit more optimization that's needed if it's a larger model to do, just because of what the limitations are with augmented reality. This is what your scenes really look like once you've got your model in there. As you know in the bottom, that's your display of what you would see in the HoloLens. It's black, but then you got your piece of equipment. That means it's actually transparent, and so when you actually put it into a HoloLens and see it, like on this floor, for example, you'll only see the piece of equipment, not the background. The other side of what we do with augmented reality is on the field side. And one of the big things is remote assistance. We have piloted and tested it with risk assessment That's great for us is because a lot of times machines go down, whether a part breaks, whether there's a fire, whatever may happen. And generally we send out a lot of people, last minute, and it's super expensive to send out maybe 10 to 15 people. And when they get there, they realize only one person really needed to go out because of this particular issue or breakage. And so with remote assist, is you can see some samples from the Hololens, and then we have somebody in the top right doing the risk assessment, is we're allowed to bring people in to basically see what I see, be able to draw on it and communicate before they need to send out the right people. But we get to send out the right people once we understand that through this. Some of the lessons learned that we have learned with augmented reality, especially on the plant floor for us, internet connection has to be good for quality streaming. If the internet connection isn't strong or you've got a lot of traffic on it, oftentimes our video we found is very grainy and it's hard to see what they're actually looking at. The other thing we learned too is that the user wearing the headset obviously kind of forgets that they have the headset on, and so they're moving around really quick and looking around, and with that it creates a very shaky video feed. So we're trying to experiment with what can we do to fix that. We've talked about basically fixing a HoloLens on a tripod if it's going to be an extended use and those kind of things, which are not ideal, but currently there's no video stabilization, and that's kind of been one of the things that has been big for us with trying to get remote assist.
So that's a
actionable
training issue too. That we train the people that are going to be wearing the headset. Hey, remember to move slowly. Don't make jerky movements. Don't walk right up on the machine. A lot of times they want to walk up and look right at it, really close to their face, thinking that they're showing you a better view. When really you need to stand back a little bit to get a bigger picture of where they're at, so that the people watching it remotely can understand exactly what they're showing.
And we found when we tell them move slower than you think, they'll do it for about 5 seconds and then go back to how they normally are. So it's hard for them. Another side of it is the layout tool. This is a tool that Microsoft has created. It uses their import tool that helps us take that file that we have and be able to convert it into something that the HoloLens can read. We use this for if we've got existing machinery that's not moving, but we need to add either a new component to it, or there's an expansion to it, or a new piece of equipment that needs to go around it. What you can see in this picture is this really is just, you start with your CAD file, or for us in Vendor, these are all the file formats that it accepts. You use the import tool, it creates a GLB, which is what the HoloLens can read, and then you've got your object. This is only downloadable through the Microsoft Store, so that's just a note if anybody's got it blocked, that's one thing you'll have to work through. And then the last component, really, that this is what we're diving into the most, is training. We know that there's a need for training, that's smarter training, better training. As you can see in these pictures, that's what all our manuals look like oftentimes. Now, we've converted most of them to PDFs and PowerPoints, but we're trying to find what can we do to make it more interactive, what can we do to make it smarter, how can we get better retention. And for us, it's really through augmented reality. And the bottom right picture is kind of an example of one of our processes we put through that guides you through how to do it. So the benefits of augmented reality, a big one for us is the lower technology complexity barrier. And really what I mean from that is oftentimes we found when you put someone in a VR headset that has no idea what VR or AR means, or has never seen one in person, is they get overloaded visually when you close off their vision from the real world. Sometimes they get disoriented. There are people, no matter how many times you tell them you'll be fine, that freak out when they close off their vision. And so for us, being able to use AR where they can still see the physical space, and it's almost like a baby step into it, is really big for us. It allows us, because in our plants we have a lot of people who may have never heard of the technology. We've got older people, younger people, and this helps us kind of bring them into it. And again, the same with the overlay of the physical space. The other big component for us is the hands-free operations. If we're doing training in a plant, generally, especially if it's at a piece of machinery, they've got to hit buttons, they've got to pull levers, they've got to touch material and whatever that is. When we're in VR and you have to use the controllers or a controller, they can't do that. So with AR, we're able to have a hands-free operation, and so that you can use voice commands or use the gaze feature or gestures to be able to interact with their training. The other big component of it is data gathering.
Yeah, that allows us to not have to go out and have a complete 3D model. We have some machinery running in our plants that's over 100 years old. It's been modified, upgraded, they've modernized it and put modern controls on it, but it may be a 100-year-old piece of machinery at heart, so there's no drawings of it. And even if there were drawings, they're not accurate anymore. So, having the ability to go out there and put tags and things like that on the augmented reality side allows us to not have to model that completely in 3D, not have to go through it and figure out which one's different. We could just walk out there to the machine, you can put tags on it directly, train somebody how to do it. And so that's a huge benefit to us.
Yeah, and I think the biggest benefit to us is data gathering. If we convert training from a PDF or a PowerPoint into augmented reality and it looks successful and we're running a bunch of people through that, but we're not gathering data on it, how are we supposed to know is it effective? Is the training that we put in place originally effective? We've converted it to a new medium, is it working? And so data gathering, currently what we have is all those training guides that we've created tie back into Power BI for us so we can see how long are they on a task, what are they looking at during that task, how fast are they going through it overall. All of those analytics we can capture so we can see, is that training actually working? What can we cut out? If we converted say a 200-step training into augmented reality, but then we found we can cut that down to 40 steps instead, and they still get that same comprehension, how much time does that cut off? We're able to all see that with the data gathering.
We just got a few minutes left here.
Yep.
I'm going to save a couple minutes here for questions. Anybody have any questions? Everybody's ready for beer 30? Yes, sir. What's your question?
What's the largest model you've imported into Unity for Hololens?
Physical or triangles or polygons? I don't know if
To say the one I played with that almost worked.
Tandem mixer, yeah, that
Yeah,
was
well, it was
several million polygons.
No, it was like 5 million polygons.
Yeah.
And if you have no texture on it, it's actually not too bad. But once you start adding textures, that's what becomes an issue. We try to keep them down. If we put an entire model in there that's an entire assembly line that could be, if you think about it, equate it to 20 to 30 yards long, do we really need to put that big of a piece of machinery in there? Can we break it up into different steps or different areas? What's important. So we always look at that when we're trying to figure out what we're doing in VR design review or why we're doing it to see what we need to actually put in there.
Have you looked at streaming the model yet?
Streaming the model?
Yeah, so that you don't actually load the whole model.
We actually did look at offloading the processing power from the headset to a computer. We haven't gone too far with it yet because it's kind of just expensive. And for what we use it for today, it's not necessary. If we start moving into where we're having the whole plant essentially in a VR style model, that's definitely where we'd have to look at offloading it.
The other side is being in dead zones and Wi-Fi and things like that.
Yeah.
We see it with the HoloLens 2 coming out. That's going to be a little bit better with the Azure tie-in. But also we run into the issue of confidentiality and no cloud and all those kinds of things that everybody else I think runs into as well.
Yep.
So second question real quick, your data gathering, how are you doing data gathering in your VR, AR environment?
So the data gathering, so the training side of it, Microsoft has a program in preview called Guides. It's similar to what other companies out there have done with their headsets, but what it allows us to do is tie it directly into Power BI. So it's pulling data directly from that Guides application. So every time someone launches it, it basically sets a recording of, okay, I'm going to record, and it says, okay, they looked at these 5 training guides, for example, and then it goes through how long did they look at them, where were the tasks, how long did they stay on the task, and all of that basically set up in a template in Power BI. So every time someone runs it and it connects back to the internet or back to the cloud, it updates our guides or our Power BI dashboard to let us know a new user's gone through it. This is the statistics from it.
You're not looking at actual what they interact with in the model.
So what we're trying to do next with that is the validation side of it. So if someone's going and doing a task and someone's not standing there watching them do that task during that training, what we're trying to do with the validation is require them to take a video or a picture of it that ties back into the analytics. So at that step, it took them 5 minutes to do this step, but now we have a video recording of that step that shows us what they did. So we could say, actually should have taken them 2.5 minutes. Why were they taking 5 minutes? Yep.
And then some of the AI stuff that's coming out, the next gen.
Yep.
And also some of the next big thing, have an AI go through and validate, did they click on the right thing or did they hit the right button or whatever you told them to do?
Yeah, we're looking for object recognition so that when they hit a button or pull a lever, that it recognizes they pulled the right lever versus the wrong one. And that's part of the AI initiative.
Anybody else have any questions? think we're done. Appreciate everybody. Oh, one more. All right.
So a lot of our machinery, so we're a Japanese-owned company, and in Japan they do a lot of their R&D and figuring out what kind of machines do we need, and they kind of do like a baseline design on the machine, and then that comes to the US, and what our team does is go, how do we make this work for our American plants? And so at that point, it's not usually conceptual, so it's generally not, oh, we need to make a machine, where do we start? But it's more, we've got a baseline, how do we build upon that? And part of that is, it starts with a drawing or a CAD file or whatever it is, and then we can build the 3D from there to start figuring out through that design review in VR with the engineers as they're trying to convert it or design new components for it. We do that in VR, but generally a lot of what we do design-wise comes from Japan, or they're small-scale parts, and so they just kind of start modeling it in Inventor and go from there.
All right, guys, I think we're out at the time for the day. I think we're going to have the exhibit hall open. I think the bar opens in about 50 minutes. We're going to hang around here. If anybody has any further questions, we'll be happy to answer them. With that, thank you guys for coming by today.
Thank you.
Appreciate it.